Hello everyone, welcome to the CVG 3148 lab. In our first lab, we will be building steel cages for our beam specimens. Our first lab includes 4 sections. First, I will introduce a reinforcement that we will be using in our experiment. Next, I will show you how to properly bend the stirrups. Then, we will tie the stirrup and the reinforcement together. Finally, we will be installing the strain gauge on the rebar.
In total, we have 5 different rebar sizes that will be used in this lab. Those 4 rebars are used for the main tension steel, while this 6.3 wire will be used for the stirrups and compression bars. The first rebar is a 15M, which will be used for beams A and A1. The second rebar is a 20M, which will be used for beams B and B1. The next rebar is 25M, which will be used for beams C and C1. The last bar is a 30M, which will be used for beams D and D1. Beam A and B will be designed as under reinforced beams. Beam C is designed to have a reinforcement which is slightly above the balance section. And beam D is designed as over reinforced beam. The 6.3 mm wire has a nominal diameter of 6 mm. 15M bar has a nominal diameter of 16 mm and cross-sectional area of 200 mm squared. 20M bar has a nominal diameter of 19.5 mm and cross-sectional area of 300 mm squared. 20M bar has a nominal diameter of 25.2 millimeters and cross-sectional area of 500 millimeters squared. 30M bar has a nominal diameter of 29.9 millimeters and cross-sectional area of 700 millimeters squared. To build stirrups, we will cut the 6.3 millimeter wires into 60 millimeter pieces. Here we see this sample is already cut into 60 millimeters. This is the bending tool that we are going to use for the stirrups. First, we are going to bend the wire to make the first hook. Next, we are going to make the other straight sides of the stirrup with 90-degree bends. Finally, we are going to make the other hook. Now we are finished. The stirrup has a length of 190 millimeters and a width of 97 millimeters. We have built enough stirrups for those cages. To tie the stirrups and rebars together, we will use the steel loops and twister. The loop has a length of 200 millimeters. Next, we have to mark the location of the stirrup. First, we need to find the midpoint of the rebar. The constant moment region is 750 millimeters in total. Therefore, the shear span is 375 millimeters from the midpoint. The other span is similar. The length of the shear span is 741 millimeters. As mentioned in the lab manual, the spacing of the stirrups is 100 millimeters. Therefore, we will place 9 stirrups in each shear span. Note that the end stirrup has a spacing of 41 millimeters. The black lines are location of stirrups. We have placed the stirrups in their locations. We placed the stirrups in the shear span, but we did not have any stirrup in the constant moment region. Now we will use the loop and twister to tie stirrups and tension bar together. First, we use the loop across the rebar and stirrup. Then pull and twist with the twister. It is done. To ensure it is fixed, repeat again. Then we have to do the same for all the stirrups. Now we will repeat for the compression bars. Note we should try to keep the stirrups vertical. Now we finish this cage. Here's the comparison between the flexural and shear cages. It is noted that our shear cages also had continuous compression bar at the top. The flexural cage has stirrups in the shear span with a spacing of 100 millimeters, while the shear cage does not have stirrups in the shear span, only contains 2 stirrups to support compression bars. This is a strain gauge. It allows us to get strain readings during the test. This is a grinder. We'll use it to get a perfect smooth surface on the rebar to install the strain gauge. This is cotton with alcohol. We will use it to clean the grinder surface. This is glue. We will glue the strain gauge to the surface of the rebar. This is solder. We're gonna use it to extend wires. First, we're gonna use the grinder to get a smooth surface on the rebar at the midspan. Next, we will use cotton to clean it. Then we will glue the strain gauge on the rebar. We need to press around 15 seconds to make sure that the glue is dry. The last step is to use soldering to extend the wire. We used the multimeter to test if the strain gauge was successfully installed. It gives us a reading of 120 ohm, indicating that the strain gauge is well installed. Finally, we need to seal the strain gauge to avoid damage during casting.
We are now done building the steel cage. In our next lab, we will be showing the procedure for the casting of the beam.